Okay, students, for example, if you want to design solar grid connected system, so how you will design the basic information I will share here with you. For example, you can see here that yeah, the total radiance available is 100 watt per meter square, and you can see here if the efficiency of the solar is 20%, then 20% of this 100 watt will be only 200 watt per meter square. And if the cable efficiency is 98%, then 98% of 200 will be 196 you will get. And if inverter efficiency is 95%, it means from 196, 95% of 196 you will get 186.2. So in this way, from the input of radiance, total radiance of 1000 watt per meter square, after getting these efficiencies, due to these efficiencies, the output net output will be 186.2 watt per meter square. So the efficiency of the system will be the product of PV cable and inverter efficiency. For example, this one, and this one. Just multiply this efficiency will be system efficiency output divided by input multiply 100. So this is actually 18.62. So in this way, the system efficiency is actually the product of the three efficiencies. Now, when we design the system, for example, standalone system, so we need this sequence. For example, the load demand, we need load demand, and the losses if there are any losses, and then the equivalent sun hours which are required, which are available for that specified location. And then after these deciding these three factors, we decide the PV array design, and then there is a charge controller, and then the battery design, and the number of autonomy days of autonomy, that means days of autonomy is that it means that battery, how many days the battery can provide the backup. So days of autonomy we need, and then we decide the inverter design, and this is the final stage. But if we want to design the grid connector system, only we need no need of a battery and charge controller. We only need the basic data of PV array by taking these three parameters, three load data, load and sun, and three type of data. Then we design the PV array and then directly design the inverter. So let's decide this first one, second, third, and fourth, and then fifth. So for example, first one for example, uh, we calculate our load. For example, we have four lights available at our home. The power per item is 25 watt. One light bulb is 25 watt. So total power is for four uh, lights, 25 multiplied 4, this will be 100. And if it is we are using 3 hours per day, so it means 100 multiply 3, so 300 watt hours energy. Similarly, for TV is 1, and the power of the TV, rating of the power TV is 100 watt, and only 100 multiplied by 1 is 100, and we use TV for 2 hours every day, so 2 multiplied 100, 200 watt. Similarly, desktop computer, for example, uh, that is 100 watt, and 100 multiplied by 1 is 100 watt, 100 watt, and we use only for 1 hour, so 100 multiplied by 1 is 100 watt. So when we count these 300, 200, and 100, we will get the 600. So now we want to design the grid connected system for the load of 600 watt. Okay, uh, keep it in mind, 600 watt. So let's start. This our load is 600 watt. There is a grid connected system, and the PV array is here, and the efficiency of the cable we already decided 98%. For example, here we decided that it is 98%, and this is 95%. So you can see here that 95% of inverter efficiency and cable efficiency is we have taken 98%. So 600 watt, you will see that for 600 watt, uh, 600 watt divided by this efficiency 0.98 and multiply 0.95, and we'll divide, we'll get this. So it means for 600 watt at the load side, we need the PV array, the generation of 644.5 watt hour, so that we can get 600 watt at the load side by considering these two efficiencies. So for example, the next design process is sun hours. How many hours the sun is available per day. So normally we take average, for example 4.5 hour per day for any specified location. So you can see here there is a panel specification, there is a panel p vary. For example, this panel is available. You have to decide. You will go to the market, what type of panels and what's the specification of the panels available in your local area. You will decide those panels and the specification of the panels will be available. For example, power output will be 100, maximum power point voltage is 16, maximum power point current is this, open circuit voltage is this, and short circuit current is 7. So it means this for maximum power point, for example, you can consider that the maximum power point is tracking is available. So you will take the maximum power, these readings data. So maximum minimum wattage, what will be the minimum wattage? 644.5 divided by 4.5. 644.5 actually this one 644.5, and you will divide this one by this hours, the available hours. So you will get 143.2 watt. It means my minimum wattage we need from the panel is this one. So but our panel is 100 watt. You see our panel is 100 watt here. So it means 143.2 divided by 100. Number of panels is 1.4. It means more than one panels are required. So it means panel will be two. We'll decide two panels. So for the two panels, you can see here the short circuit current is 7 ampere. Maximum current will be 7. 7 is actually the short circuit current, and the open circuit voltage is 20 volt. So maximum current will be for two panels 7 multiplied to 14 ampere, and maximum voltage will be 20 volt multiplied to 40 volt. It means a maximum voltage will be 40 volt and maximum current is 14 ampere. So now we'll decide. For one panel, the power wattage was 100 watt. Here you can see that there is a 100 watt this one, and multiply by 2 because we are using two panels. 100 multiplied by 2, this is 200 watts. Now the inverter, how we decide the inverter? For example, inverter is this inverter is available. It should be more than 200 watt. So the next size of inverter is this one. 300 watt inverter is available, and the specification of this 300 watt inverter is the maximum voltage is 50 volt and current is 8 volt, 8 ampere. It is operating on MPPT. So 50 volt is greater than Vmax. Vmax is actually, Vmax is this maximum voltage for two panels which we are designing. So this is 40 volt. This 40 volt mean this voltage of the inverter is greater than that 40 volt, but the current of 8 ampere, but here the current was 14 ampere. It means this 8 ampere is less than maximum current. So it means this inverter current is 8 ampere, but our panel, if we will connect the panel in parallel, so it will draw the 14 ampere. The inverter cannot withstand, cannot afford this 14 ampere because inverter maximum current is 8 ampere. So it means we cannot connect the panels in parallel. We have to connect the panels in series 40 volt. So because 40 volt is within the range of this inverter voltage, so it means we will connect the panels in series, two panels in series, and then the output of the PV panels will be connected to the inverter and then to the load. So in this way you can design the PV system.